Hello and welcome back to Survey of Biology. As we go on to section 4 of Unit 11, we're talking about genetic variability and diversity, and this one is going to look specifically at mutations, but how mutations can lead to cancer. So if you remember in section 3 we talked about mutations and what can cause mutations, but now we're going to look specifically at those mutations that are carcinogens that can lead to cancer. And what happens is in cancer is that the cell loses control of the cell cycle and it divides out of control. If you remember back several units, we talked about the cell cycle and how normally cells will go from G1 to S to G2 to mitosis and divide, but many times they'll go to G0 where they're just mature functioning cells. And so what happens is a normal cell will accumulate mutations. And those mutations will mean that it has uncontrolled proliferation or division. They have lost control of the cell cycle, and that's what can lead to a tumor in the cells that we might see cancer in. So here's an example of 4 generations. We've kind of got our normal cell, I'll call it the P generation for parental. And what happens is as that cell divides, in the first generation we may get 1 mutation. And here the cell seems normal, but it's predisposed to proliferate or divide excessively. So probably nothing comes out of it at this point. When we go to the second generation, now let's just say because of random, remember mutations are random, because of random chance, a second mutation accumulates in this cell here on the end, and the cell begins to proliferate too much, but is otherwise normal. We go to a third generation, and now a third mutation will accumulate. And here the cell's still proliferating more rapidly, but now we've got structural changes. So it's starting to become a cancer cell. And now we go to a fourth generation, and we have a fourth or more mutations that accumulate, and we get a malignant cell that's visibly different. And it looks, here it's called deranged, but the big thing is it's growing uncontrollably. That's going to lead to a tumor from there. So let's look at what genes are responsible for controlling cancer. So when we talk about cancer, one of 2 things usually has to occur. One is we have these genes called tumor suppressor genes. And normally they're turned on because they suppress tumors. They keep us healthy. They keep cells from dividing too much. And when we run into trouble is when those tumor suppressor genes get turned off. So if there's a mutation in a tumor suppressor gene and turns it off, we can have issues. The other one are oncogenes. And these ones are normally off. And it's when oncogenes get turned, proto-oncogenes get turned on, they become oncogenes, and this can lead to uncontrolled cell division. So let's look at oncogenes first. So let's look at the example on the top here. So here's a normal oncogene, and so normal oncogenes regulate cell growth, okay? And in this form, they're called what are known as proto-oncogenes, and they regulate cell growth. And it's only if there is a mutation, you see, or damaged proto-oncogene that the proto-oncogene becomes an oncogene, and then the oncogene accelerates cell growth and division. That's what can lead to cancer. So when proto-oncogenes get turned on, they can become oncogenes, which leads to cell growth and division, which can lead to cancer. So here's an example of cars with a brake. So here's our normal genes. These are ones that are called proto-oncogenes. Now if there's a mutation and that proto-oncogene gets turned into an oncogene, the car or the cell loses its brake, and we're going to have a big crash over here because the car's going to accelerate, the cell's going to divide out of control. So here's an example of our normal cell. So if we start at the top here. Now if some cancer-causing agent, ultraviolet radiation, X-rays or something, causes this proto-oncogene to become an activated oncogene, that's what causes it to turn into a cancer cell, which is going to divide out of control and can lead to a tumor. Now the second one is these tumor suppressor genes. And in the normal cell, they're on. We want them to prevent cancer. Okay? They're suppressing tumors. Now when tumor suppressor genes become mutated or activated, then they don't do their job, and the damage can lead to cancer again. So here's kind of the opposite. Tumor suppressor genes should be on, but if they get turned off because of a mutation, they're not going to be able to prevent the uncontrolled division that we see. So on the left here, here's our tumor suppressor gene, and it has normal growth inhibiting protein, and it keeps cell division under control. It keeps it healthy, like if we need to replace skin cells. But if we have a mutated tumor suppressor gene, that protein is defective, it's not functioning, the cells grow out of control, and that's what can lead to cancer. So here's an example. The one I want you to look at are these two genes called BRCA1 and BRCA2. And so they are for inherited breast cancers. And they are tumor suppressor genes. So if BRCA1 or BRCA2 is damaged, then the DNA can't be repaired, and that's one example of a tumor suppressor gene being turned off that can lead to breast cancer. So real quick, and I know we didn't go into a lot of detail, this is a quick example of the two types of genes, proto-oncogenes and tumor suppressor genes, that can be mutated and lead to cancers. So again, thank you for your time, and we'll talk to you soon.